Hey everyone, today we're talking about leukocyte function as we age. Our immune system will undergo characteristic and multifaceted changes with aging. These changes can occur in all leukocytes, and so it's going to affect, our innate and adaptive immunity. Although certain immune responses will be diminished with this aging, others are going to be unaffected or even exacerbated. Just like the article talked about inflammaging, which results from exposure to continuous antigenic stress. It's going to lead to the upregulation of cellular and molecular processes, and then it's going to favor susceptibility to age-related diseases. Studies would indicate that ROS production may be altered in aging as superoxide anion levels from aged neutrophils are lower than those from young neutrophils. Meaning that those concentrations are going to get higher with aging and can diminish those functions. Eosinophil and basophils play a central role in the pathogenesis of allergic inflammation and protective immunity in response to parasitic infections. Aged mice are the ones that are actually displaying a greater airway response to this than young mice in the study that they had done, meaning that, as these mice are aging, the eosinophils are kind of remembering, well, this is how we do it, and then they're just sending way too much. So that's suggesting that the eosinophil effector function, which I am assuming is kind of like a pause button, is declining with aging, so it's just going to shoot all of them out at once. Aging-associated changes with monocyte and macrophage have been recognized as major contributors to the dysregulation of the immune system in a variety of disease processes. Because macrophages are highly plastic, and so whatever environment they are, they're going to change and adapt to that specific environment. So if you're already having a disease, you've already modified the function of your macrophages, and if you are continuously getting sick, these are continuously degenerating, from my understanding of that section. I also liked the part where it was talking about telomeres and how how they're diminishing as we age because we're doing more and more of these copies, and telomeres are kind of just extra parts of your X chromosomes. They're just there to say, because our bodies know that as we age, as we do all of these copyings, some of the data is going to get lost. So this is like our junk, with a baker's dozen, you have 13, so if you burn some, well, you still have the cookies. That's kind of what telomeres do. So as these keep getting shorter and shorter, you're running into the risk of it actually cutting into the good part of the DNA. And in macrophages, the telomere shortening leads to decreased proliferation in response to GM-CSF. So we're not proliferating as much. We're not getting that differentiation that we need in order to clear these infections. Although reduction, our phagocytic capacity is getting reduced, so it's taking longer for it to clear out all these infections because we're not having a lot of these macrophages anymore, or they're just too small to really even do anything for us, so that's getting diminished. Our memory and naive human T cells it says that they don't really like lose their age, like lose their function, but when we age, you know, our thymus diminishes, and so even though the T cells that we have are good, there's not enough to really do anything for us in response to these infections. Also saying that it's going to also affect apoptosis as we age. So as we know, apoptosis is like is programmed cell death. So it's this specific cell that we want to kill. That's what apoptosis is. Well, if that function diminishes as it does with aging, we might be killing off the wrong things, or killing it too soon, or letting it get too old and damaged and then killing it. But by that time, you know, our body's like, well, we need to make more cells, so they're going to use this like decrepit cell, and can't think of a better word for it, and then that's what leads to some diseases and neutrophils not acting as they should. It talked about B cells, and they were reduced significantly in the elderly. And it is found that memory B cells decline with age, and those naive B cells increase with age. So the ones that we want both. Obviously, you know, we want to remember what infection we have to be able to kill if we get that infection again. But if those decrease and naive B cells come on, you know, if you've been vaccinated, this is when your body's like, well, I don't remember like how to fight that. So you have to keep re-upping these vaccinations, like shingles and influenza. And if you keep getting naive cells, well, they're not going to know what to do. So they're going to, you know, just shoot off as much as they can and try to clear the infection as best they can, but they're not doing it as effectively. How does this affect health? Well, you know, as you get older, you know, you're not fighting off your infection as effectively. You run the risk of having whatever infection you have longer and it worsening and then damaging like important tissues. And for signs that you might see that indicate immune dysfunction is occurring, well, if after all of this stuff, the infection gets worse, or instead of just this one infection, now another area of the body is this is not working properly. We have super infections now. I mean, that's more of a, well, we take antibiotics for everything type deal, not like our body actually doing it. But again, that's also going to cause your immune dysfunction, because we're giving so many antibiotics. Your body's like, well, why do I need to make these B cells, or why do I need to make these neutrophils if you're just going to put medicine in here to help me kill it? So it all plays, aging does a lot to the body, and it's just important to, you know, keep yourself as healthy as you can, you know, do your hand hygiene, make sure what you're putting in your body is good for you, and just keep on top of protecting yourself against infection. Thank you.